when conductivity of semiconductor is only due to breaking of covalent bonds, then the semiconductor is called. See here, as far as n-type semiconductor or p-type semiconductor is concerned, conductivity of n-type semiconductor can be increased by increasing the number of impurity atom added to it. Number of pentavalent impurity atom means by increasing the number of either phosphorus atom added or arsenic atom added or antimony atom. Number of phosphorus atom or number of arsenic or number of antimony atom, as they are increased, every phosphorus or arsenic or antimony atom will donate one free electron. Ultimately, it helps in increasing the conductivity of n-type semiconductor. Similarly, conductivity of p-type semiconductor, it can be increased by increasing the number of trivalent impurity atoms like boron or aluminium or that of indium. Every trivalent impurity atom will create vacancy of electron, means will create a hole, means will accept an electron. So, by increasing the number of impurity atoms of boron or aluminium or indium, we can increase the conductivity of p-type semiconductor. And because n-type and p-type semiconductor, they are known as extrinsic semiconductor, means conductivity of extrinsic semiconductor can be increased by increasing the doping level. What is the doping level or percentage doping? Doping level or percentage doping means what number of impurity atom were added as an impurity to pure germanium or silicon crystal. Greater is the percentage of doping or doping level, greater is the conductivity of n-type or p-type or extrinsic semiconductor. But as far as intrinsic semiconductors are concerned, what are intrinsic semiconductor? Pure germanium crystal or pure silicon crystal, they are intrinsic semiconductor. Remember, germanium or silicon, they belongs to fourth group of periodic table. They belongs to what? Fourth group of periodic table, means they are tetravalent. Tetravalent means they are having 4 electrons in their outermost orbit. And we know that when germanium has 4 electrons in their outermost orbit, in order that germanium atom to become stable, how many electrons are needed in the outermost orbit? It requires 8 electrons. So, for stable electronic configuration, every germanium atoms needed 8 electron in its outermost orbit, and that can be achieved in germanium crystal because every germanium atom, it becomes stable by sharing 1 electron each from 4 of its neighboring germanium atom, so that number of free electron in the outermost orbit of every germanium atom, they are 8 in number, and this happens due to formation of 4 strong covalent bond with 4 of its neighboring germanium atom. Remember, as far as these covalent bonds are concerned, they are strong. They are strong enough at absolute zero temperature. Means at absolute zero temperature, covalent bonds are strong, means no free electrons are available. No free electrons are available in intrinsic semiconductor, but at room temperature, as we increase the temperature of intrinsic semiconductor, what happens? With the increasing temperature of intrinsic semiconductor, these covalent bonds, due to thermal agitation, as they acquires energy due to thermal agitation, so covalent bond, they becomes weak, and after some time, when their temperature reaches a certain minimum level, then these covalent bond, they will break down, and when covalent bonds are break down, means free electrons are available for conduction of electricity, And remember, number of free electrons available for conduction of electricity, it is directly proportional to temperature of intrinsic semiconductor. In other words, as the temperature goes on increases, then number of free electrons goes on increases. So remember that in case of intrinsic semiconductor only, here the conductivity of intrinsic semiconductor can be increased only due to breaking of covalent bond. So out of 4 options, option B, that is intrinsic semiconductor, is the correct option for this question. So you remember that the pure germanium or silicon crystal, they are known as intrinsic semiconductor, while germanium or silicon crystal, when they are doped either with trivalent impurity or with pentavalent impurity, they are known as what? Extrinsic semiconductor. And the electrical conductivity of N-type semiconductor, P-type semiconductor or extrinsic semiconductor can be increased by increasing the number of impurity atom added to it. So as far as this question is concerned, when the conductivity of semiconductor is only due to breaking of covalent bond, then the semiconductor is called intrinsic semiconductor. So B is the correct option for this question.